We want to talk about three special triangles, special right triangles, and their respective ratios. Okay, so let's remember again what I mean by the ratios given a right triangle. So if we have a right triangle here, there's my angle theta, and let's label our sides x, y, and r. Then my three ratios that we talked about, sine of theta is equal to y over r, the cosine of theta is equal to x over r, and then the tangent of theta is equal to y over x. Okay? Now, the three triangles that we're going to construct and then discuss their ratio, and I say three, but I really mean two, and you'll see what I mean. We want to talk about the 45-45-90 triangle, the 30-60-90 triangle, and the 60-30-90 triangle. These two triangles are really the same thing, but we're going to look at them from different views, and hopefully you'll see why I chose to do it that way. All right, let's start with our 45-45-90 triangle. Okay, and we're going to construct it. Let's get some focus. From a square. And let's start with a square where each side is of length 1. Okay? If I were to cut my square in half with this diagonal, it would cut the angles at the corners in half. All my angles around a square are 90 degrees, so if I cut them in half, I have 45 and 45 in those corners. Let's pull off that triangle and look at it alone, okay? So what I have is 45, 45, 90, and this side is 1, and this side is 1. I now need to figure out what this side is. Well, I'm going to use my Pythagorean Theorem that I told you we were going to need to remember. And that tells me that this side squared plus this side squared equals my hypotenuse squared. So 1 squared plus 1 squared, which equals 2, is equal to r squared. So the square root of 2 is equal to r. I know it's only the positive square root because I'm talking about distance. Okay, so that tells me this distance right here is the square root of 2. All right, so we can now talk about those three ratios. The sine of 45 degrees is equal to the opposite over hypotenuse, or 1 over the square root of 2. Sometimes you will see that rationalized, and it'll look like this, the square root of 2 over 2. Those are one and the same. The cosine of 45 degrees is adjacent over hypotenuse, also 1 over the square root of 2, or the square root of 2 over 2. And lastly, the tangent of 45 is equal to opposite over adjacent, or 1 over 1, which is just 1. All right, so we are going to want to remember these ratios on this very special triangle. All right, let's move to the 30-60-90 triangle, and we're going to start with an equilateral triangle. And what that is, that's a triangle where all three sides are the same, which means all three of my angles are the same. And if a triangle has 180 degrees, divide that by 3, each angle measures 60 degrees. Let's just say my side is of length S. Doesn't matter, it's some particular length, but it's equilateral, so they're all the same. Now, let's cut this triangle in half by dropping down this perpendicular line to the base. And so that'll cut this angle in half, so each one of those angles will be 30. So let's come over here and pull off that triangle. So that's 60, that's 90, and that's 30. This distance right here is S. Since this distance was S, half of it is going to be 1/2 S. This is the height here, and I don't know what it is in terms of S, but I'm going to find it, again, using the Pythagorean Theorem. So I know that 1/2 S squared plus this unknown height squared should equal my hypotenuse squared. All right, so I have enough information to solve for H. So H squared equals S squared minus 1/2 squared, or minus 1/4 S squared, if I square that whole quantity. So S squared minus 1/4 squared gives me 3/4 s squared. Taking the square root of both sides, positive square root, because again we're talking about distance, the height is going to be equal to the square root of 3 over the square root of 4, which is 2, times the square root of s squared, which is s. So my height in this particular case is the square root of 3 over 2s. Okay, so this is the relationship to all those sides. So let's use that information to write our ratios. So the sine of 60 is going to be equal to h over s, or the square root of 3 over 2s over s. Those will cancel, and I'm left with the square root of 3 over 2. All right, the cosine of 60 is going to be equal to 1/2 s over s, this side over this side, or just 1/2. The tangent of 60 is going to be equal to this side, the square root of 3 over 2s over 1/2 s, which equals the square root of 3. Okay, so these are the ratio values for this 60, 30, 90 triangle. Now, to look at the 30, 60, 90 triangle, really it's just going to take this triangle and we're going to turn it. So let's draw that picture. And all those, we don't have to recalculate the sides because the sides are going to be the same length. So if I were to draw 30 and pretend like this is more to scale than it looks, 30, 60, 90, remember that this side was the square root of 3 over 2s. This is still s, and this one is 1/2 s. Okay, so now it's going to be pretty straightforward to find my ratios here. So the sine of 30 is going to be equal to 1/2 s over s, or 1/2. Recall, okay, well, let's not recall yet. The cosine of 30 is going to be the square root of 3 over 2s over s, or the square root of 3 over 2. Notice this doesn't matter what my s is, it's just the ratio. The tangent of 30 is going to be 1/2 s over the square root of 3 over 2s, or 1 over the square root of 3. Now, that's some really important triangles and their ratios. And you should be able to construct a chart to organize that information. And your chart should contain this. So given your angle, so we looked at 30 degrees, 45 degrees, and 60 degrees. You should be able to find the sine of that angle, cosine of that angle, and the tangent of that angle. So our angle is in theta. So we decided that the sine of 30 was 1/2, and the cosine of 60 was 1/2. The cosine of 30 was the square root of 3 over 2, and the sine of 60 was the square root of 3 over 2. Interesting. Oops, we can't see. Focus. Focus. And focus. Sine of 45 was 1 over the square root of 2, as was the cosine of 45. The tangent of 30 degrees was 1 over the square root of 3, as the tangent of 60 was the square root of 3, and then the tangent of 45 was 1. Know this chart.